The strangest fact about light you've never heard. There is something extraordinary hiding in plain sight. Every sunrise, every glowing screen, every distant star, every reflection in a puddle carries the same mysterious traveler: light. We think we know it because we see it every day. We believe it is familiar because it fills every moment of our lives. But the deeper science looks, the more unsettling the truth becomes. Light refuses to behave the way anything else in the universe behaves. It challenges intuition, bends logic, and quietly rewrites our understanding of reality itself. Imagine holding a flashlight in your hand. You press the switch, and a beam races into the darkness. It feels simple, almost ordinary, yet what leaves that flashlight is unlike anything else known to science. It has no rest. It has no experience of standing still. It moves through the universe at a speed so fundamental that space and time themselves rearrange to protect it. Most people believe they understand light because they live with it every moment of their lives. It pours through windows at sunrise, paints the sky with brilliant colors at sunset, reflects from every face we recognize, and allows us to navigate a world that feels familiar and predictable. It seems so ordinary that we rarely stop to question what it truly is. Yet the greatest scientific discoveries often begin by looking more carefully at the things we think we already understand. Light is perhaps the most extraordinary example of this. Hidden beneath its everyday appearance lies a mystery so profound that it has transformed humanity's understanding of space, time, matter, and the universe itself. Imagine waking up tomorrow in a world without light. There would be no colors, no shadows, no stars scattered across the night sky, no glowing horizon announcing the arrival of morning. Vision itself would disappear because every image your eyes have ever seen depends entirely on light, making an incredible journey before reaching you. Every face, every mountain, every ocean, every page you've ever read has been revealed by countless tiny messengers racing across space. We often think we are simply looking at objects, but in reality, we are seeing light that has interacted with those objects before arriving at our eyes. Our experience of reality is built almost entirely from information carried by light. For thousands of years, people wondered what light actually was. Some believed it flowed like an invisible stream. Others imagined it spread through space like ripples across water. As scientific understanding advanced, each new experiment seemed to answer one question while creating several more. Every attempt to place light into a simple category failed. It behaved in ways that no ordinary object should. Sometimes it acted like a continuous wave spreading smoothly through space. Other times it behaved like tiny packets of energy arriving one by one with astonishing precision. Instead of choosing one identity, light seemed to exist beyond the limits of everyday intuition. This is what makes light so remarkable. The closer we examine it, the less it resembles anything in our daily experience. It refuses to follow the expectations built from throwing a ball, watching rainfall, or observing moving cars. Nature reveals that the universe is not obligated to match the instincts developed through ordinary human experience. Those instincts evolved to help us survive on a single planet under familiar conditions, not to understand the deepest architecture of reality. Even more surprising is that every discovery about light has expanded our understanding far beyond light itself. By studying its behavior, scientists uncovered hidden properties of electricity and magnetism, revealed the flexible nature of space and time, unlocked the strange rules governing atoms, and discovered clues about the birth and evolution of the cosmos. A simple beam from a flashlight and the faint glow of a distant galaxy are connected by the very same physical laws. The light reaching your eyes from a nearby lamp obeys the same principles as light that has traveled across billions of light years from the edge of the observable universe. Perhaps the strangest part is that none of this mystery is hidden in some distant corner of the cosmos. It surrounds us every second of every day. Every reflection in a mirror, every rainbow after a storm, every star shimmering overhead, and every screen illuminating your face carries the fingerprints of one of nature's deepest mysteries. What appears to be the most ordinary feature of existence is, in truth, one of the greatest puzzles ever encountered by the human mind, For most of human history, motion seemed simple. If you throw a ball while standing still, it travels at a certain speed. Throw that same ball while riding in a moving vehicle, and someone standing beside the road measures a different speed. This idea feels so natural that we rarely question it. Motion appears to depend entirely on the observer. Every experience in everyday life reinforces this belief. Whether it is a bicycle, an airplane, or a rocket, speeds seem to add together in predictable ways. It is exactly what common sense expects. Yet hidden within the behavior of light is a fact so astonishing that it overturned centuries of scientific certainty and forced humanity to rethink the nature of reality itself. Imagine standing beside a road as a car drives past with its headlights on. You naturally expect the light from those headlights to move faster than light emitted from a stationary source because the car is already moving. That expectation seems perfectly reasonable. If motion adds to the speed of everything else, why should light be any different? Scientists once believed the same thing. It matched every observation of ordinary objects and every instinct developed from daily experience. But when experiments became precise enough to measure the speed of light under different conditions, the results were deeply unsettling. No matter how fast the source moved, no matter how quickly the observer traveled, light always arrived at exactly the same speed. This was not a tiny difference hidden within measurement errors. It was a completely unexpected feature of nature. Every careful experiment reached the same conclusion. The universe seemed determined to preserve one unchanging cosmic speed, regardless of who was making the measurement. It was as though reality itself refused to allow light to behave like any ordinary object. At first, this discovery appeared impossible. Scientists searched for mistakes in their instruments, questioned their methods, and explored countless alternative explanations. But the evidence continued to grow stronger. Eventually, it became clear that the mistake was not in the experiments, but in humanity's assumptions about space and time. The astonishing solution was that light does not adjust its speed to match the universe. Instead, the universe adjusts itself to preserve the speed of light. Distances can shrink. Time can flow differently for observers moving at different speeds. Events that seem simultaneous to one observer may occur at different moments for another. These effects are not illusions created by faulty perception. They are genuine properties of reality revealed by countless experiments and technologies used every day. Consider astronauts traveling at enormous speeds through space. Although the effects remain tiny at ordinary velocities, they become increasingly significant as motion approaches the speed of light. Clocks moving rapidly tick more slowly compared with clocks at rest. Measuring rods appear shorter along the direction of motion. These changes are not mechanical defects but natural consequences of the structure of space-time itself. The universe reshapes measurements of distance and time to ensure that every observer measures exactly the same speed for light. This realization transformed physics forever. It connected space and time into a single unified framework, replacing the old picture of separate, absolute dimensions. Every beam of sunlight, every signal crossing a fiber optic cable, every photon arriving from distant galaxies silently obeys this remarkable rule. Light is not simply moving through space. It defines the deepest limits of how information, energy, and cause can travel throughout the cosmos. The constant speed of light is far more than a number. It is one of the fundamental principles upon which the universe itself is built. When we think about a journey, we almost automatically imagine the passage of time. A traveler leaves one place, moves through space, experiences moments one after another, and eventually reaches a destination. Every trip we have ever taken follows this pattern. Whether it lasts a few minutes or several years, time accompanies every step. We measure distance by asking how long it takes to travel. Our lives are organized around clocks because time feels inseparable from motion. Yet the deeper laws of physics reveal a startling possibility. The universe contains a traveler that challenges this familiar picture, and that traveler is light. Every particle of light, known as a photon, races through the universe at the fastest speed nature allows. It leaves the blazing surface of a distant star crosses unimaginable stretches of empty space, slips through galaxies, avoids clouds of gas and dust, and eventually arrives at a tiny planet where it might enter your eye. From our perspective, this journey can take millions or even billions of years. Entire civilizations could rise and disappear, while a single photon continues its silent voyage across the cosmos. The universe itself changes dramatically during that immense span of time. Stars are born, galaxies collide, and planets evolve while light patiently continues toward its destination. The remarkable idea emerges when physicists examine this journey through the framework of relativity. According to our best understanding of nature, the faster an object moves, the more slowly time passes for it compared with observers moving at lower speeds. This effect is not an illusion or a trick of perception. It has been confirmed repeatedly through experiments involving precise atomic clocks, fast-moving particles, and spacecraft. Time itself is not fixed. It depends on motion. As an object's speed approaches the speed of light, these effects become increasingly dramatic. Time slows more and more relative to stationary observers. At the ultimate limit, where a photon always exists, the familiar concept of elapsed time reaches a boundary that challenges ordinary intuition. From our perspective, light may spend billions of years crossing the observable universe. Yet the mathematical description suggests that the usual experience of time simply does not apply to a photon in the way it applies to us. The beginning and the end of its journey become connected in a profoundly unfamiliar manner. This does not mean that photons possess awareness, memories, or conscious experiences. Modern physics does not attribute thoughts or feelings to particles of light. Instead, it reveals that the structure of space-time treats light in a fundamentally unique way. The equations describing the universe place photons on the very edge of what time can mean. They occupy a special role unlike any object with mass. Their existence exposes the limits of human intuition, reminding us that reality often extends far beyond everyday imagination. This realization transforms the night sky into something far more extraordinary than a collection of distant lights. Every star shining above you is connected to your present through countless photons that have traveled across space under laws unlike anything in ordinary life. Some began their journey before the first humans walked the Earth. Others left their galaxies long before our solar system even formed. Every beam of starlight carries not only information about distant places, but also a reminder that time itself is woven into the fabric of the universe in ways that continue to surprise even the greatest scientific minds. Every time you look into the night sky, you are performing an act that feels completely ordinary. You raise your eyes, notice the moon, the stars, perhaps the faint glow of distant planets, and assume you are seeing the universe as it exists in that very moment. It feels immediate, as though the cosmos is presenting itself to you in real time. Yet one of the most astonishing truths in science is that the universe never appears exactly as it is now. Every image reaching your eyes is a message from the past, carried across space by light. The farther away an object is, the older the message becomes. In this sense, light transforms the entire universe into a vast archive of history waiting to be explored. Consider the moon, our closest celestial neighbor. Even its light requires a little more than a second to reach Earth. When you gaze at the lunar surface, you are seeing it as it existed just over a second ago. That delay is almost impossible to notice because it is so short. Now think about the Sunday. The sunlight warming your face began its journey roughly 8 minutes before it reached Earth. If the Sunday could somehow vanish instantly, we would continue seeing it in the sky for those final 8 minutes because the last rays of light would still be traveling toward us. The information carried by light always arrives with a delay, no matter how small or how enormous the distance. As our attention moves beyond the solar system, the delays become extraordinary. The nearest stars appear as they were several years ago. Some of the brilliant stars visible on clear nights are showing us events that happened before a child entering school today was even born. More distant stars reveal conditions from centuries, thousands, or even millions of years in the past. Entire galaxies appear as they existed long before human civilization emerged. Their light has crossed unimaginable distances without stopping, carrying ancient stories through the darkness until finally reaching our telescopes. This remarkable fact changes astronomy into something far more profound than simply observing distant objects. Every telescope is also a window into history. The larger and more powerful the telescope becomes, the farther into the universe it can see, and the farther back in time it can look. When astronomers observe galaxies billions of light years away, they are witnessing the universe during its youth. Some of the faintest light ever detected began its journey shortly after the universe itself was born. Those ancient photons have spent nearly the entire history of the cosmos traveling through expanding space before arriving on Earth. This means the observable universe contains a timeline spread across the sky. Nearby objects reveal the recent past, while distant galaxies reveal progressively earlier chapters of cosmic history. Looking farther into space is not merely seeing greater distances, it is exploring earlier moments in the evolution of the universe. Scientists can watch galaxies forming, stars igniting, and enormous structures gradually taking shape because light preserves these ancient events during its endless journey. Perhaps the most fascinating realization is that nearly everything we know about the cosmos has come from decoding these ancient messages carried by light. Every color, every spectrum, every tiny shift in brightness or wavelength contains clues about temperature, motion, chemical composition, gravity, and age. Light acts as the universe's messenger, faithfully transporting information across billions of years without words, allowing humanity to reconstruct a story that began long before our planet existed and continues to unfold across the immense canvas of space. Centuries, scientists believed that everything in nature could be placed into clear and familiar categories. A thing was either one type of object or another. Water flowed like a liquid. Rocks remained solid. Sound traveled as a wave through air. Tiny grains of sand behaved like individual particles. These distinctions felt permanent because they matched everyday experience. The universe appeared to follow simple rules that our senses could easily understand. Then, light revealed a truth so unexpected that it challenged the very foundation of how humanity describes reality. The deeper scientists investigated, the more light refused to choose a single identity. Imagine standing beside a calm lake and dropping a small stone into the water. Circular ripples spread outward in every direction, overlapping with one another as they travel. This behavior is the defining feature of waves. They spread continuously, interfere with one another, and create patterns of peaks and valleys. For many years, experiments suggested that light behaved exactly like this. When beams of light passed through narrow openings or around obstacles, they produced beautiful interference patterns identical to ripples crossing the surface of water. The evidence seemed overwhelming. Light was a wave, but another series of experiments revealed something completely different. In certain situations, light behaved as though it arrived in tiny, individual packets of energy. Instead of flowing continuously, it struck detectors one discrete event at a time. These packets, called photons, behaved like particles with measurable amounts of energy and momentum. Suddenly, the elegant picture of light as a simple wave collapsed. If light truly consisted only of waves, these observations made little sense. Yet the experiments were undeniable, repeated countless times with extraordinary precision. At first, scientists searched for a way to preserve the old categories. Surely light had to be one thing or the other. Perhaps one set of experiments was incomplete. Perhaps hidden details had been overlooked. But as technology improved, every new discovery strengthened the same astonishing conclusion. Light behaves like a wave when traveling through space, producing interference and diffraction patterns that only waves can create. Yet when interacting with matter, it often behaves as individual particles, delivering energy in precise, localized amounts. Neither description alone captures the full truth. This strange dual behavior became one of the cornerstones of quantum physics. The universe was revealing that the familiar categories built from everyday experience were not fundamental laws, but limited descriptions suitable only for ordinary scales. At the microscopic level, Reality follows principles that resist simple visualization. Light is not switching costumes between experiments. Instead, it belongs to a deeper framework where the mathematical description succeeds even when ordinary language struggles. Waves and particles become complementary ways of describing different aspects of the same underlying reality. One of the most famous demonstrations of this mystery is the double-slit experiment. When light passes through two narrow openings, it creates an interference pattern that strongly suggests wave behavior. Yet if scientists reduce the beam until photons travel one at a time, the same interference pattern gradually emerges after many individual detections. Each photon arrives as a localized event, yet together they build a pattern associated with waves. It is as though every photon carries within it the hidden possibilities of multiple paths before finally appearing at a single point of detection. The deeper physicists explored this phenomenon, the more they realized that nature is under no obligation to satisfy human intuition. Light became a profound reminder that reality is often richer than the mental pictures our minds naturally create. The universe does not simplify itself to fit familiar categories. Instead, it invites us to expand our understanding, replacing certainty with curiosity, and revealing that even the most ordinary beam of light carries within it one of the deepest mysteries ever uncovered by science. Every great scientific discovery creates the illusion that humanity is approaching the end of its search. A mystery is solved, a theory is confirmed, and for a brief moment it feels as though the universe has finally surrendered one more of its secrets. Yet history tells a different story. Each answer becomes the doorway to even deeper questions. The more we understand light, the more we realize how much remains hidden beyond the limits of our knowledge. Light has revealed extraordinary truths about the universe, but it has also exposed mysteries that continue to challenge the greatest scientific minds. One of the deepest unanswered questions is surprisingly simple to ask. Why does light travel at the speed that it does? Modern physics measures this value with astonishing precision, and countless experiments confirm it again and again. It is woven into the equations describing space, time, energy, and gravity. Yet the equations themselves do not explain why nature selected this particular value instead of another. It is one of the fundamental constants of the universe, a number so deeply embedded in reality that changing it even slightly would reshape the cosmos in unimaginable ways. Stars might never form, chemistry could become impossible, and life as we know it might never emerge. Another profound mystery lies in the relationship between light and gravity. According to our understanding of gravity, massive objects bend the fabric of space-time itself. Light, despite having no rest mass, faithfully follows those curves. This remarkable effect allows galaxies and black holes to bend light like enormous cosmic lenses, magnifying distant objects hidden far beyond them. Astronomers routinely use this phenomenon to study parts of the universe that would otherwise remain invisible. Yet at the deepest level, gravity and the quantum behavior of light belong to two different mathematical frameworks that have resisted every attempt at complete unification. Quantum mechanics describes the microscopic world with extraordinary accuracy, predicting the behavior of particles and light to astonishing precision. General relativity explains gravity, planets, stars, galaxies, and the large-scale structure of the cosmos with equal success. Individually, both theories have passed every experimental challenge placed before them. Yet when scientists attempt to combine them under the most extreme conditions, such as inside black holes or during the earliest moments after the birth of the universe, the equations begin to conflict. Somewhere beyond our current understanding lies a deeper theory capable of embracing both descriptions. But that theory remains one of the greatest goals in modern physics. Light also continues to illuminate mysteries that extend far beyond itself. Observations of distant galaxies reveal that the universe is expanding faster and faster, driven by an unknown influence often called dark energy. Meanwhile, the visible matter illuminated by stars accounts for only a small fraction of everything that exists. Most of the universe appears to consist of invisible dark matter, detected not because it shines, but because its gravity influences the motion of galaxies and bends passing light. We can observe its effects with remarkable confidence, yet its true nature remains hidden. Perhaps the greatest lesson is not that science has failed to answer every question, but that every beam of light continues to guide humanity toward deeper understanding. Each new telescope captures older light from more distant galaxies. Each new experiment measures light with greater precision than ever before. Every discovery expands the boundaries of knowledge while revealing an even larger horizon beyond. The universe does not become less mysterious as we learn more about light. Instead, light continually reminds us that curiosity is one of humanity's greatest strengths, carrying us ever closer to truths that still wait beyond the edge of today's understanding.